Cumulative distribution functions. Cumulative, it means you add up. Cumulative distribution functions, better known as CDF. Cumulative distribution function. Okay, it is defined for all real numbers, B, where B is in between negative infinity and positive infinity by this definition. F for B is equal to the probability that the random variable is less than or equal to B. You add up all the probabilities of x's as long as those x values are less than b. In other words, if you have a random variable that can take on the numbers -2, 7, 13, and 104, and 144. And let's just make believe that the probabilities of these are 1/12, 1/20th, 1/10, 1/4, and whatever that needs to be to make these 5 numbers add up to 1. I'm not going to calculate that. If you want to know, f of 13, that is, by definition, the probability that the random variable is less than or equal to 13. Well, x can be 13, 7, or -2. This is nothing more than the probability that x is 13 plus the probability that x is 7 plus the probability that x is identically -2. So you would add up those 3 numbers, because p of 13 is a 10th. P of x equaling 7 is a 20th. And p of x equaling -2 is a 12th. It's not an arithmetic class. I'm not going to add them up for you. But that's how you find f of a number. You add up all the probabilities where the random variable can be that number or below. It's just adding them up. Cumulative. Okay, but now it could get more complicated. Suppose that f of b is given to be this. Sometimes it's given to be 0. Sometimes it's known to be x over 2. Sometimes it's 2/3. Other times it's 11 over 12. And other times it's 1. Well, you may ask, when is it these values? Excellent question. It's 0 if x is less than 0. It's x over 2 if x is between 0 and 1, can equal 0. If x is between 1 and 2 equals 1, could equal 1. That will give you 2/3. To get 11 over 12, that's when x is between 2 and 3, it can equal 2. And it's 1 if x is 3 or more. And for some reason this didn't come out. F or B is equal to this. So there's a few questions. Find the probability that x is less than 3. Find the probability that x is identically 1. Find the probability that x is more than a half. And find the probability that x is in between. That's the symbol for x is in between 2 and 4. And it can even equal 4. I'm going to find these probabilities. Okay. Now, how you might think of this is, see, f of 3, I don't know if I want to say this. Alright, what I want to say is the following. So again, we want to know the probability that x is just less than 3. That x is continuous. There is no first number less than 3. There is no first number that x can be that's less than 3. So what you need to do is the probability of x is less than 3. Now, which is equal to, not plus, excuse me. That's going to equal to the probability that x is less than or equal to 3. The reason I want that is because that one is just f of 3. And to use, this is the only one that allows x equals 3, so it's going to be 1. Okay. But the problem is this equal sign isn't valid yet. The left side says x can equals 3. The left side doesn't allow x to equals 3. The right side does. So we need to take away. We need to take away somehow p of 3. So what I'm going to call it is the limit of p of x is less than or equal to 3 minus 1 over n. I'm going to let n go to infinity. 1 over n is getting smaller and smaller. And I'm doing 3 minus smaller and smaller and smaller. It'll always be a little bit less than 3. But now it says less than or equal to. So it's the limit as n goes to infinity of f of 3 minus 1 over n. It's 1 minus the limit as n goes to infinity. Now, n is some positive number, and, these numbers are all less than 1. So you have 3, and you're taking away a little. A little bit less than 3 is here. X can be less than 3. So it's always 11 over 12. In fact, this result isn't even a function of n. So you get 1 minus 11 over 12, which is 1 over 12. So that is the answer to the first one. We did that one. What about the probability that x is identically 1? The probability that x is exactly 1. Now, sometimes you're given that information, but not in this problem. We're not given the PDF, the probability distribution function. We're just given the cumulative function. We have no other information than what's given to us. So we can find the probability that x is equal to 1. Okay. Not directly, at least. The probability that x is 1, well, this is the probability that x is less than or equal to 1 minus, so now we're including less than 1. We don't want that. We're including less than 1. So we need to take away everything less than 1. It's the limit as n goes to infinity of the probability that x is less than or equal to 1 minus 1 over n. Because if you have 1 and you take away 1 over 2, or you have 1 and you take away 1 over 3, if you have 1 and you take away 1 over a million, if you have 1 and you take 1 over a billion away, if you have 1 and you take away 1 over a gazillion, you're going to be just less than 1. But that's just what we want. Like, here's a number line. This probability says you can equal 1 and be below. This one says to take away everything below 1. Everything below 1. And all that survived is 1 itself. And that's just what we wanted. The probability that x is exactly the number 1. So you have to think and be clever, but you should always, can't really think when you would add 1 over n, but either you add or subtract 1 over n. Alright, so now this is equal to this probability I can write using f notation. It's just f of 1 minus the limit as n goes to infinity of f of 1 minus 1 over n. Now f of 1, x can equal 1 here. X can be less than 1 here, but not equal to. So I plug in 1 here, which just gives me 2/3. Minus the limit as n goes to infinity. Now this is, if n is sufficiently large, this is always going to be a little bit less than 1. And if you're a little bit less than 1, you use that rule. And what's in between the brackets is n, is x. So it's x over 2. It's 1 minus 1 over n over 2. Now this is 2/3, that 2/3, minus this limit. Well, as n goes to infinity, that goes to 0. 1 over really, really large numbers. If you have one piece of candy and you share it between a million people, well, everyone gets 0. And if you say, no, they don't, they get 1 over a million. You're absolutely right. Just divide it by more and more people. Eventually, it tends to 0. So you just have minus a half. This is 8 over 12 minus 6 over 12, which is 2 over 12, or 1/6. So that answer is simply 1/6. Okay. What if let's do the third one. So obviously we just did the probability that x is exactly 1. And the reason these are drastically different looking is because we don't know how to calculate the probabilities directly. We're not told we have an urn with 22 balls. Some are red, some are green. What's the probability of getting a green one? Alright. The probability that x is bigger than a half. Well, what's the complement? It's 1 minus. If you're not bigger than a half, that does not mean you're less than a half. It does not. It means you're less than or equal to a half. So this is 1 minus. The probability of x being less than any number just becomes f of that number. But it has to say less than equal, not just less than. So it's 1 minus f of a half. Our half is between 0 and 1, so I use this rule. X is the half divided by 2. It's 1 minus a quarter, which leaves you 3/4. If you have $1 and you spend 1/4, you have 3/4 left over. Okay, let us try the last one. The probability that x is in between 2 and 4, but it can equal 4. Now, this is probably the hardest one. But you just have to think carefully. If you think about it carefully, actually no math problem is hard. The hard thing is to think about it in the right way. Okay. So we have this problem before us. Probability that x is in between 2 and 4, but it can only equal 4. Now, I'm going to use the space on the bottom for a number line. We just need to be able to write this using less than and less than equal symbols. It being x is between 2 and 4. Now, if I say that x is less than or equal to 4, that's good because that's just f of 4. So here's 2 and here's 4. Right now, I say x can equal 4 and be below. So I do have between 2 and 4. What I don't want is 2 and below. I want to remove 2 and below. I want to remove 2 and below. I want to take away the probability that x is less than or equal to 2. That will give me above 2 to 4. But this is straightforward. The probability that x is less than anything is f of the anything. And now I know how to find f for 4. 4 is bigger than 3, so probability is 1, minus f for 2. This one here, it says x can equal 2. So I plug 2 in here. It's not my fault, it's a constant. So you have 1, and you take away 11/12, you are left with 1/12. Okay, that finishes that problem. Just awkward, pain in the neck type of problems. Let us try another one. You're given the CDF, and you're asked to find certain probabilities. And the CDF is always denoted by capital F. The CDF is denoted as follows. Sometimes you get 0, sometimes you get b over 4, sometimes you get 1 plus b over 4, sometimes you get 11 over 12, say, and other times you get 1. Now, when do you get these? If b is less than 0, if b is in between 0 and 1, including the 0, if b is in between 1 and 2, including the 1, you get 11 over 12 if b is in between 2 and 3, including this 3, including the 2, and b is bigger than 3, or equal to 3. That's the definition of the CDF function. And we want to find a few of these. We want to find the probability that x is 2 first. Well, our CDF gives us from a number all the way down to negative infinity. Remember, b was defined between negative infinity and infinity. A CDF only gives us the probabilities if you're less than or equal to some number. For now, we're equal. We're equal to a number. So we're going to write the probability that x is less than or equal to 2. because that certainly equals 2. But it also includes the numbers less than 2. Now that's what we don't want. Somehow we need to take away all of these. So we take away the probability that x is less than 2 minus a little bit, 1 over n. And how do I make sure it's a little bit? I let n go to infinity. And I guess you can write n here and say n goes to 0 plus. But we're not, or we did it. This one, since it's the probability that x is less than or equal to something, that's f of the something, minus the limit as n goes to infinity of p of x is less than or equal to that. Well, that's just f of that, 2 minus 1 over n. Now, f of 2 is straightforward because we can use our rule. Here, b can equal 2, or x can equal 2. You get 11 over 12. Minus. This is a little bit less than 2. And if you're less than 2, you use that rule. So it's the limit as n goes to infinity of 1 plus 2 minus 1 over n, 2 minus 1 over n, all over 4. But if n's going to infinity, that's going to 0. So if I may continue up here, you get 11 over 12 here, minus 3/4. 1 plus 2 is 3, minus 3/4. 3/4, if I multiply top and bottom by 3, so these denominators are the same, get 11 over 12 minus 9 over 12. 11 minus 9 is 2 over 12, which is a 6. The probability that x is exactly 2, given this cumulative distribution formula, is 1 out of 6. 1/6. Okay, let's do 2 more of these. Okay. What if we want to find the probability that x is identically 3? You need to start catching on. They're all done the same way. You do the probability that x is less than or equal as 3. Well, if you're less than or equal as 3, you equal 3 just like we want, but you're less than as well. Well, somehow we need to remove these. And we have to remove it by saying p of x is less than or equal to. So, minus, we say 3 minus 1 over n. And if n gets bigger and bigger and bigger, this gets closer and closer to 3. But always above. Always just below 3. And that is why we are taking away everything just below 3 and more. X is less than, we're taking away all the probability that x is less than numbers just below 3. This is a number just below 3, and we're taking away everything less than that as well. So we only are left with 3, which is perfect. Now this here, since this p of x is less than or equal to something, namely 3, that's just f of 3. Minus, then it has this limit stuff, the limit as n approaches infinity of the probability that x is less than or equal to. Once you have this, you say it's f of that. Okay, f of 3. This one allows b or x to be 3, and f of that will be 1. F of 3 is 1. You have to remember how to evaluate piecewise functions. Go back to your pre-calc book. This is going to be a little bit less than 3. So I'm taking f for things less than 3. A little less than 3. That's always 11 over 12. And this time we get a 12th. Because this number, 1, is 12 over 12. You take away 11 over 12, you're left with the 12th. Okay. Now, the last one, the last part I did, I said was the hardest one so far. This one's going to be a little bit harder. What is the probability that x is between 1/2 and 3/2? X is between 1/2 and 1 1/2. Probability that x is in between 1/2 and 1 1/2, 3/2, strictly. Okay, so what we ultimately want is only between these two numbers. We ultimately just want that. We don't want to include the endpoint. We just want 100% in between 1/2 and 3/2. Well, if we do the probability that x is less than or equal to 3/2, well, that includes 3/2 and everything below. Now we need, this is the one we want, and what's below is what we have. Well, the first thing is I have to take away, or I could first take away the fact that it equals 3/2. If I remove this one, then it becomes an open circle. Okay, now I need to remove some more. I need to remove from 1/2 and below. I need to remove from 1/2 and below. And then if I do that, it'll be open at 1/2, and now I have exactly what's above. So I need to take away the probability that x is less than 1/2. It's actually a drop easier than I thought to take away that. Okay. So the first probability is straightforward. The probability that x is less than or equal to that number is just f for that number. I'm going to do the last one first, or next, minus the probability that x is less than or equal to that number. Well, that's just f of that number, and minus. Now when it comes to equalities, how are we going to handle that one? Yeah, maybe this is the hard one. How do we do that? How do we do x equals 3 over 2? We can do the probability that x is less than or equal to 3 over 2. That gives me 3 over 2, but it gives me what's below 3 over 2 as well. So we need to take that away. And there is no first number right below 3 over 2. That is why we need to do the probability that x is less than 3 over 2 minus 1 over n, and then say, hey everyone, n is going to infinity. Okay, let's do this math. F of 3 over 2, 3 over 2 is 1 1/2. It's this one, so I use that rule. 1 plus 3 over 2 over 4 minus f of 1/2. 1/2 is in here. So I get 1/2 over 4. 1/2 over 4, which is an eighth. Minus p of x equaling 3 over 2. Well, actually, this here is f for 3 over 2. You have f for 3 over 2 and you are taking away f raised 3 over 2. So we don't even need this. We didn't even need that. Now we have to take away the probability that x is less than 3 over 2 minus 1 over n. That's a little bit less than 1 1/2, which is still in here. Okay, we have the limit as n goes to infinity of 1 plus b, 1 plus 3 over 2 minus 1 over n over 4. What I will quickly say is, to make life a bit easier, you can change this operation to addition as long as you change the second one. If I multiply this number by 2, I get 1. And if I multiply that number by 2, I get 8. That is, a half over 4 is an eighth. Plus, well, if n is going to infinity, then 1 over n is going to 0. So it's 1 plus 3 over 2 over 4. I am going to multiply each of these terms by 2 to get rid of that denominator. When I multiply 1 by 2, I get 2. When I multiply that by 2, only the numerator survives. When I multiply that by 2, I get 8. The nice thing is, I have a common denominator. This is 5 over 8, and I'm taking away 1 over 8. That's 4 over 8, which reduces to the number 1/2. They're messy, fair enough, but you're in a probability theory class. You need to be able to do this. Just watch these two problems 10, 20 times over and over. The reason I'm not going to do more is because they're all exactly the same. They are exactly the same, and if you could understand these two examples, you could understand all of the examples. Good luck.